This is 8.1a of Algebra. So monomials, here's a couple examples of what monomials look like, okay? So it's going to be a number with a variable or just a variable or just a number, but there won't be any plus signs or minus signs involved, okay? So these are each like one unit, right? Those are all monomials. So the degree of a monomial is the sum of its exponents. So this one doesn't have any exponents, right? So it has a degree 0, because if it had some exponent after it, let's say like x, it would be x to the 0 power, right? So when it's just a number, when it's a constant, the degree is 0. This one has like a 1, right? It's not written there, but we know there's a 1 there. So this would be a degree 1. This one would be a degree 2. This one, there's an invisible 1, right? There's always a 1 there. So x to the first, y to the third. So this would be a degree of 4, because 3 plus 1 is 4. Right? So let's try a few examples. So we're going to look at our 3 problems down here and figure out their degrees. So if there aren't exponents written, write them. So this is x to the first, y to the first. So 1 plus 1, that's 2. So this is a degree 2. This one, well, we've got an exponent on our y. We don't have any on our z, so that's z to the first. So 4 plus 1, that's 5. So this is a degree 5. Notice that the number out front, the coefficient, doesn't matter at all. And this last one has no exponents, so this is a degree 0. It has no variables with exponents, I should say. Okay, adding and subtracting monomials, okay? So we combine like terms. They have to be the same. This is going to be a little bit of a long route to do this, but hopefully it'll make sense. Let's try our own problem, not one they gave us yet. Let's say we have just 2xy squared plus 3xy squared. Right? They both have the same thing after it. If it helps you, put it in a different word. So maybe bananas, okay? So 2 bananas, so we're sticking in bananas instead of the box there, plus 3 bananas. 2 bananas plus 3 bananas, well, that gives us 5 bananas. So that gives us 5, and then instead, if we put the box back in there, 5xy squared. Whatever you're adding is going to stay the same. You don't have to change exponents, that sort of thing. Okay, so let's try ones that they have. They have negative 6x to the fourth plus 11x to the fourth. Well, these are the same, so we can add them. Negative 6 plus 11, it's a positive 5, so that's 5x to the fourth. Let's say they're not the same. So 4pq squared plus 2pq. This one is different from this one. You can't add it. You would just leave it exactly like that. You can't combine them. Let's try their last problem there. 2x squared y to the fourth minus 7x squared y to the fourth. So these two things are the same. So 2 minus 7, that's negative 5, and we can stick on the x squared y to the fourth. Okay, so a polynomial is when you put a bunch of monomials together. Okay, poly means many. All right, so you're putting many monomials together. And we want to stick it in standard form, and that's when we put the highest degree first, then the next lowest degree, and the next lowest degree, and the next lowest degree. Right, so you hear this has a degree 4, this one has a degree 2, this one has a degree 1, this one has a degree 0. So it was 4, 2, 1, 0, right? You start with your biggest and go to your smallest. Alrighty. And we can figure out the degree of a monomial. So the degree of a monomial is the sum of its exponents. The degree of a polynomial, so one of these guys, is whatever the highest degree is. So in this case, this has a degree 4 because that's the biggest degree of a monomial. Right? So a polynomial is made up of monomials. Each of these is a monomial. Think of them as like train cars if you want. Okay? You can figure out the degree of each monomial, which they did down here. Okay? And then to figure out the degree of the polynomial of this whole thing, you're going to take the highest degree of one of the monomials. okay? And we have different ways to name these, okay? So you name them based on the degree and based on the number of terms, okay? So here's our chart for basing it on degree, okay? If it's a degree 0, it's just a constant. If it's a degree 1, it's linear. Degree 2, it's quadratic. Degree 3, it's a cubic. And a degree 4 or higher, it's like 4th degree, 5th degree, 6th degree, that sort of thing. Then, based on the number of terms, here's our table. So if there's one term, right, that's what we looked at the beginning, that's a monomial. If there are 2 terms, that's a binomial. If there are 3 terms, it's a trinomial, right? Bi means 2, tri means 3, tricycle, triangle, that kind of thing, right? And if we have 4 or higher, so 4 plus, that's just a polynomial. So you give something 2 names based on its degree and based on the number of terms. So if we look at this one that they gave us here, it's a degree 4, right? That's the highest term. So it's a 4th degree. And there's 1, 2, 3, 4 terms, so it's a 4th degree polynomial. So they gave us a polynomial here, 2x minus 3 plus 8x squared. Okay, I'm going to stick little brackets under here. Here's one of our monomials. Negative 3, the negative needs to go with it. And 8x squared, right? So what's the degree of this 2 to the x? Well, there's a 1 there, right? So this is degree 1. This doesn't have any variables. This is a degree 0. And this is x squared, so it's a degree 2. So we need to rewrite those in order from biggest to smallest based on their degree. So the 8x squared goes first because it has a degree 2, plus 2x because that has a degree 1, and minus a 3 because that has a degree 0. And then we can name it. So the first thing we can look at is naming it for its degree. So the highest degree was a degree 2, right? So this is a quadratic. And there are 3 terms. So this is a trinomial. So its name then is a quadratic trinomial. And there's your homework.